Hello.
Good evening, sir.
Yeah, good evening. Uh, we'll continue with the AOD theory discussion. There is a little bit of theory that is left, uh, and we'll do some practice problems. We'll first start off with the two questions I had given at the end of the last class. First was prove that mod of cos alpha minus cos beta is less than equal to mod of alpha minus beta. So again, here we can use an appropriate function to try to prove this inequality. So the function that you can select here is f of x is x plus cos x. And let's try to find out how this function behaves. So if you think about it, the derivative of this function will be what? 1 minus sine x, right? Correct. And the derivative is always positive, correct? So this means that fx is a monotonically increasing function because the derivative is always positive, right? And because it is monotonically increasing, then we can assume two cases. Case one, where alpha is greater than equal to beta. In that case, it is an increasing function. So f of alpha will be greater than equal to f of beta, right? Which means alpha plus cos alpha will be greater than equal to beta plus cos beta. And from here, we get cos alpha or cos beta minus cos alpha is less than equal to alpha minus beta. Do you see? It's the same thing. I've just written this side. I've brought this term this side. And that's all, right? So case one, you are seeing if you take modulus of this, you'll get mod of cos alpha minus cos beta is less than equal to mod of alpha minus beta. And similarly, you can do case two also. For alpha less than equal to beta also, you can do similar things. Is everyone understanding what I'm saying? How you can prove it?
Yes, sir.
Choose an appropriate function, understand whether that function increases or decreases, and then you can solve the problem. You can prove it both the cases. I have shown you one case, you can do the other case also. The second question was this one. For 0 is less than x is less than pi by 2, you have to prove that cos of sine x is greater than sine of cos x. Okay. Anybody has tried this?
सर ट्राई किया
नहीं हो रहा है.
तो मतलब ऐसे केस लेके कि 0 से π/4 में साइन इंक्रीजिंग है फिर वो वैसे कर
समझ
साइन
में आ रहा है क्या हो रहा है? Were you able to come to conclusion or no?
नो सर
Okay, so again, we'll use the concept of increasing and decreasing, but we have to choose an appropriate function here. For example, if I choose a function, just like previous case, we chose x plus cos x, right? Here, I will choose x minus sin x. Guys, you have to mute yourself if you're going to make noises in the class. I think it is Aditya. Please mute yourself. Okay, f of x is equal to x minus sin x is my appropriate function that I can think of here. If you take the derivative, you will realize it is 1 minus cos x again, and that derivative is clearly greater than equal to 0. Actually, it is greater than 0 because our x is not equal to pi by 2, right?
यस सर
So that means f of x is strictly increasing function. Okay, so for all x between 0 to pi by 2, this function f of x is increasing, right? So if you take this point 0 and this point x, what I know is that x is bigger than 0, right? Correct?
Yes.
X is bigger than 0. So what do I know? F of x will be higher than f of 0, right? Do you understand what I'm saying?
Yes, sir.
By the increasing function property, and so we are saying x minus sine x will be greater than 0. X is greater than sine x. And now you can take cos on both sides, right? If x is greater than sine x, what kind of function is cos x in this interval? Is a decreasing function, no?
Yes, sir.
Cos x function is decreasing in this range. So if I apply a cos of x to both sides, what should be the inequality right now?
इनइक्वालिटी चेंज हो जाएगी.
Right. You should get this, right?
Yes, sir.
Okay. So what we are getting is cos x is less than cos of sine x, right? Correct.
Correct, sir.
And now let's compare this cos of x with the sine of cos of x. Think about it. Just now we have shown that x is greater than sine x, no?
Yes, sir.
So what can you say about sine of cos of x and cos x? Which one is will be bigger in this region? देखो इस रीजन में x was bigger than sin x, right?
Yes.
So cos x is also a term somewhere in this region only, no? Cos x भी तो एक value होगा somewhere between 0 to pi by 2, right? 0 to 1 actually, right? Think of cos x as the new x. Which one will be bigger?
So cos x function will be bigger.
Do you understand this part I'm saying? From here I'm saying.
Yes, understood.
Because the argument, the angle is bigger than the sine of it. Therefore, if cos x was the angle, it will be bigger than sine of the cos x, right?
Yes.
So therefore, now we have this inequality and this inequality, and you can see now the combination of these two tells us sine of cos of x is less than cos x is less than cos of sine of x. Do you understand? So
Yes.
again, we are using the property of increasing and decreasing functions to figure this out. The next problem that you have to think about is slightly different. You have to find the global maxima and global minima for f of x equals to tan inverse x minus log base ex on the interval 1 by root 3 to root 3. Everyone should be able to do this.
सर एफ ऑफ एक्स ये डिक्रीजिंग फंक्शन है, तो एफ ऑफ रूट थ्री पे इसकी मिनिमम वैल्यू आएगी और वन बाई रूट थ्री पे मैक्सिमम आएगी।
करेक्ट। 1/√3 में मैक्सिमम आएगी, जो टू पुट द वैल्यू 1/√3 एंड √3, राइट? I hope it is clear to everyone what is happening here. This function, if you take the derivative is always less than 0, so it is decreasing. Whenever a function is decreasing or increasing on an interval, maxima minima will always happen at the end points. I hope that is not new to you guys. So maxima will happen here at the first point, 1/√3, and minima will happen at the second point. Okay. The next problem is f of x is given by this function x cube minus x square plus 10x minus 5. This is for x less than equal to 1, and minus 2x plus log base 2 b square minus 2 for x greater than 1. You have to find possible values of b such that fx has a maxima at x is equal to 1. You have to find the set of possible values of b so that fx has a maxima at x is equal to 1.
सर बी की वैल्यू है
Mhm.
-√130 से -√2 यूनियन √2 से √130।
Mhm. That is correct. और सब लोगों को भी मिल रहा है कि बस प्रहलाद ही बस तुम ही सॉल्व कर? What about the other guys? Aditya, what happened?
Yes, sir.
हो रहा है?
Yes.
So for maxima, what is the condition that we have to apply here?
डिफरेंशियल।
प्रहलाद बताओ क्या क्या किया तुमने?
सर पहले डिफरेंशिएट किया
हम्म।
दोनों दोनों को लेस देन एक और वन वाली जो कंडीशन है और जो ग्रेटर देन वाली कंडीशन को डिफरेंशिएट करके इक्वेट करा है।
इक्वेट क्यों किया?
सर
क्योंकि
हमें
सर
ये पता नहीं है ना कि एफ डिफरेंशिएबल है।
In such problems you have to assume that it is differentiable. अगर differentiable नहीं होता तो फिर बोलते।
सर डिफरेंशियल अज्यूम किया तो कंटिन्यूअस भी होगा,
हाँ।
तो फिर इक्वेट कर दिया
इक्वेट क्या चीज को कर रहे हो?
दोनों इक्वेशंस को डिफरेंशिएट करके। एल एच डी बराबर आर एच डी।
तुम बोल रहे हो फॉर डेरिवेटिव टू एग्जिस्ट, नॉट कंटिन्यूअस से नहीं हो रहा है वो।
नहीं नहीं, वो मैं ऐसे मतलब डिफरेंशिएबल है ना ये, तो लेफ्ट हैंड डेरिवेटिव इक्वल टू राइट हैंड डेरिवेटिव होगा।
एट एक्स इज
सर
इक्वल टू
बिना
1।
डिफरेंशिएट करके भी आ रहा है मतलब।
बिना डिफरेंशिएट करके भी आ सकता है। नहीं, बिना डिफरेंशिएट के कैसे आ रहा है बताओ।
सर अगर हम आ रहे अगर हम सर सेकंड वाले फंक्शन में 1 डालते हैं, अप्रोच कराते हैं राइट साइड से, तो वो 5 से कम होना चाहिए।
फॉर मैक्सिमा इस वाले फंक्शन में लिमिट क्या आ रहा है? 1
5
माइनस 1 प्लस 10 प्लस 5 आ रहा है, राइट?
तो सर
तो
5
लेफ्ट
हमेशा
साइड
उससे बड़ा होना चाहिए।
सो लेफ्ट साइड से 5 की वैल्यू पे अप्रोच हो रहा है, राइट साइड से इट शुड बी लेसर देन 5, राइट?
Yes.
For this part to be 5 to be a maxima, correct?
Yes, sir.
हाँ, सो राइट साइड से लेसर देन 5 होना चाहिए, सो करेक्ट ही बोल रहे हो। सो -2 प्लस log base 2 b square minus 2 should be less than equal to 5. You're getting 7 here, and 2 power 7 128, और b square minus 2 is less than equal to 128 आ रहा है, right?
Yes, sir.
Or other condition is b square minus 2 is greater than 0 for the log to be defined, right?
Yes, sir.
Okay, so you're getting it, it's fine. Okay, the next problem is this one. You have A, B, C are positive numbers. A, B, C are positive numbers if ax square plus b by x is greater than equal to c for all x greater than equal to 0, greater than 0, then show that minimum value of a b square by c cube is 4 by 27. काफी इजी है एक्चुअली। फिफ्थ वाला इज क्वाइट इजी आई थिंक। You take the function f of x as ax square plus b by x and analyze that function. Your first derivative is going to become 2ax minus b by x square, and this will be 0 when? It will be 0 when 2a by b is equal to 1 by x cube. So x is 1 by x cube. So x should be 1 b by 2a to the power 1 by 3. At this point, the derivative is 0. You can check the double derivative to check whether it is a point of maxima or minima. So double derivative आ रहा है 2a plus 2b by x cube, right? Double derivative is clearly positive at this point. So therefore, this point is going to be a minima. And now you put x is equal to b by 2a to the power 1 by 3 into f of x, and you should be able to find the minimum value. So basically, what we are getting? We are getting minimum value will be f of x should be greater than equal to, the minimum value is coming as a into b by 2a to the power 2 by 3 plus b by 2a to the power 1 by 3. Is everyone understanding what I'm saying?
Yes, sir.
So इसको थोड़ा सा simplify करना होगा. You have A divided by A power 2 by 3. So A power 1 by 3, B power 2 by 3 divided by 2 power 2 by 3 plus here you have B divided by, so B power 2 by 3, or A will go on top, A power 1 by 3, and now it will be a 2 will go on top. So 2 power 1 by 3 on top, right? So it is basically, this stuff is common. You have A power 1 by 3, B power 2 by 3, and this is cube root of 2 plus 1. Okay, so 2 power 1 by 3 plus 1 by 2 power 2 by 3. If you take common denominator 2 power 2 by 3, on top you'll get 2 plus 1. So 3 by 2 power 2 by 3. This is what you're getting. So we are getting that f of x is always bigger than this thing, right? So what that means is c should take the place of this, right? Basically, we wanted to say f of x is always bigger than c. So c should be equal to this, no, then?
Yes.
Because this is the minimum value of f of x. So we can say c is equal to 3 by 2 power 2 by 3, a power 1 by 3, and b power 2 by 3. So you can cube the whole thing. C cube is equal to 27 by 4 a b square. And we are getting a b square by c cube is coming out to be 4 by 27 from there. I hope it is clear. It's not very difficult. It's just you have to do the calculations a little bit, right?
Yes, sir.
Sixth वाला question करो. That is more interesting. You have to try to get that one.
सर 6th वाला हो गया.
कैसे बताऊं?
सर क्या कहते हैं, इसको पहले डिफरेंशिएट करके इसके क्रिटिकल पॉइंट्स निकाले, दो बनेंगे. एक साइन एक्स ऐसे डिफरेंशिएट किया तो आया हमारा 3 साइन स्क्वायर एक्स कॉस एक्स प्लस 2 लैम्डा साइन एक्स कॉस एक्स. फिर हमने साइन एक्स कॉस एक्स बाहर निकाला, कॉमन कर दिया, तो आ गया हमारा 3 साइन एक्स प्लस 2 लैम्डा. अब ये एफ डैश एक्स है हमारा. हमने एफ डैश एक्स अगर मैक्सिमम मिनिमम वैल्यू की, हम इसको इक्वल टू 0 कर देंगे, क्योंकि स्लोप 0 होता है उस टाइम पे. स्लोप किया तो दो केस बनेंगे, या तो साइन एक्स इक्वल टू 0 या फिर 3 साइन एक्स प्लस 2 लैम्डा इक्वल टू 0.
Why is cos x not equal to 0? तुम्हारा f dash x आया था sin x cos x times sin x 3 sin x plus 2 lambda. So when I am saying f dash x is equal to 0, how are you getting two cases? Why not three cases?
सर क्योंकि क्वाड्रेटिक साइन में है ना.
Quadratic से तो कोई रिलेशन नहीं है. These are three factors.
सर मैंने sin x cos x को 2 से मल्टीप्लाई करके sin 2x के फॉर्म में लिख दिया, जिससे
That's
मतलब एक
fine.
इक्वेशन.
It's the same thing. I think this is easier. No, यहाँ पे easier है ना चेक करना कि which one is 0, right? C.
अगर cos x 0 नहीं हो सकता ना.
हाँ, वही तो बोलना है ना यहाँ पे. इस रेंज में ही देखना है ना हमको.
यस सर.
तो ये मेंशन करोगे ना कि इस रेंज में cos x 0 नहीं हो सकता है.
यस सर, हाँ नहीं हो सकता 0.
अगर मेंशन नहीं करोगे मतलब तुम ध्यान नहीं दे रहे हो फिर, राइट?
यस
इस रेंज में sin x 0 हो सकता है. sin x could be 0 at x is equal to 0, and you could also have a 0 at here when sin x is equal to minus 2 lambda by 3, right? Correct?
यस सर. फिर सो साइन एक्स की रेंज है वो -1 से 1 के बीच में, उसको कर दिया, फिर लैम्डा की वैल्यू उससे आ गई.
हाँ, तो first of all you have to make sure that there is one minima and one maxima. How do we know with what is happening here, right? ये कैसे पता चल गया कि वन मिनिमा एंड वन मैक्सिमा है? ऐसा भी तो हो सकता है तो दो मिनिमा है। समझ रहे हो मैं क्या बोल रहा हूँ?
यस सर।
तो वो भी तो चेक करना पड़ेगा ना। वी हैव टू चेक व्हाट इज हैपनिंग एट जीरो एंड व्हाट इज हैपनिंग हियर। करेक्ट?
यस सर।
द वे टू चेक दैट इज फाइंड द डबल डेरिवेटिव। The function here was 3 sine square x cos x plus 2 lambda sin x cos x, right? This was my function, right?
यस सर।
इसमें एक और डेरिवेटिव ले सकते हैं। 3 times sin square x will become 2 sin x cos x multiplied by cos x plus 3 times sin square x multiplied by minus sin x plus lambda, this is sine 2x, so derivative of sine 2x will be 2 cos 2x. This is my double derivative, right?
यस सर।
We need to check the double derivative at the two critical points. At x is equal to 0, this part vanishes, but this part is going to be positive depending on lambda's sign, right? Positive or negative, right?
Okay. Pause.
Do you understand? It depends on the sign of lambda, whether it is positive or negative, right?
Yes sir.
So if lambda is positive, this is f double derivative is positive at 0, which means 0 is a minima. It is a minima if lambda greater than 0 and a maxima if lambda less than 0. समझ में आ रहा है सबको?
Yes sir.
Similarly, at sin x is equal to minus 2 lambda by 3, also you have to check what is happening here. Before checking, you cannot conclude. So you should do that check yourself, whether it is positive or negative, what is happening. If you conclude that it is correctly coming one minima and one maxima, then to find the set of values of lambda, what we can say is sin x ki value will be from minus 1 to 1, which you have already done. Right? Do you understand what I'm saying?
Yes sir.
So from there you will get 3 by 2 and minus 3 by 2 and all. But you have to do the check whether the function is having one maxima or one minima and so on. Correct?
Yes.
Okay. The next problem is this: if the equation x power 4 plus 4x cube minus 2x squared minus 12x plus k equal to 0 has 4 real roots, find the set of values of k. इस टाइप के क्वेश्चंस को एनालाइज करने का तरीका पता होना चाहिए. Don't make any assumptions that you cannot explain. So think about it carefully. Such questions have been asked many times, so you need to understand it properly.
सर के की वैल्यू -7 से 9।
दैट इज करेक्ट। कैसे, क्या लॉजिक है बताओ।
सर सबसे पहले हमने इस फंक्शन को डिफरेंशिएट किया और
हम्म।
जीरो करके चेक किया कि किस किस वैल्यूज पे ये जीरो हो रहा है। तो
हम्म।
एक एक तो हिट एंड ट्रायल से 1 मिल गया, तो वो
हम्म।
करके फिर मैंने उसको डिवाइड किया, तो वो आई क्वाड्रेटिक बनी, उसको सॉल्व किया तो रूट आए एक x इक्वल टू -3, x इक्वल टू -1 और x इक्वल टू 1 जो हिट एंड ट्रायल से आया था।
1 सेकेंड, तुमने पहले डिफरेंशिएट किया कि नहीं?
ये सब मैंने डिफरेंशिएट किया।
डिफरेंशिएट करने से क्या है, 4x³ प्लस 12x² -4x - 12, राइट?
यस सर, फिर मैंने मतलब मेरा हिट एंड ट्रायल से x इक्वल टू 1 एक रूट आया।
x³ प्लस 3x² -x - 3, ओके। यहाँ
मेरा
पे you have to guess some roots, so you have gotten x is equal to 1,
यस
right? So then x minus 1 is a factor, then you will get a quadratic and you can factorize it, right?
यस
It should get factorized like this,
यस।
correct? फिर क्या है?
फिर सर उसके बाद जो ये रूट आ गए -3 -1, उसको ऊपर इक्वेशन में पुट किया तो k की वैल्यूज आई जो आई कि 3 - 3 पुट करने पे -9, -1 पुट करने पे
Those
7
are
और
the points of local maxima or minima, no? Why are you trying to find those values?
जो कि वही वैल्यूज पे हमें k की वो पता लगी कि किस रेंज में k लाई करता है, क्योंकि वो मैक्सिमम और मिनिमम है। ये जो टर्निंग पॉइंट्स हैं ये सारे x इक्वल टू -3 पे, -1 पे और 1 पे।
देखो, उससे नहीं पता चल रहा है कि 4 रियल रूट्स हैं। उससे थोड़े पता चल रहा है तुमको। 4 रियल रूट्स के लिए ग्राफ ऑफ दिस फंक्शन शुड इंटरसेक्ट द एक्स एक्सिस 4 टाइम्स, राइट?
यस
तो ये मैक्सिमा मिनिमा की वैल्यूज से हम लोग को के का रेंज क्यों पता चलेगा? तुम जो बोल रहे हो उससे, उसका लॉजिक नहीं मुझे समझ में आ रहा है, कोई लॉजिक नहीं है उसका। सी, what we have is the original biquadratic. You have found its derivative, you have found the points of maxima and minima. Why are you trying to find the values of maximum 1 और -1 और -3 पे फंक्शन का वैल्यू निकाल के क्या होगा?
क्योंकि सर जितनी बार वो टर्न करेगा वो दोबारा एक्स एक्सिस को कट करेगा।
तो तुम ये कैलकुलेट क्यों कर रहे हो?
ताकि सर रेंज पता लगे ना वो के की, क्योंकि मैक्सिमम वैल्यू पे ही वो वैल्यू ज्यादा होगी कम होगी, उस हिसाब से हमें वैल्यूज मिल जाएंगी। तो मतलब मैं समझा नहीं पा रहा।
देखो, तुमको ग्राफ का नेचर समझना है, राइट? एफ ऑफ एक्स का नेचर समझना है ना?
यस सर।
सो एफ, सबसे पहले जब भी कोई पॉलिनोमियल फंक्शन आता है, यू शुड ट्राई टू फिगर आउट व्हाट इज हैपनिंग एट वेरी लार्ज एक्स एंड वेरी स्मॉल एक्स, राइट?
यस
So x tends to infinity, f of infinity is tending to infinity. Can you realize that?
यस सर।
And f of minus infinity is tending to minus infinity, to plus infinity also. Because x power 4 will make it plus infinity, right?
यस सर।
तो ये तो पता है कि function will become very large at plus and minus infinity, correct?
यस सर।
Now you have to think about what is happening at these points, and for thinking about that, you have to realize कि these points are maxima क्या minima, right?
यस सर।
So what you can do is, if you have already done this derivative, double derivative also you can find. And double derivative is coming as 12x² plus 24x minus 4. At each of these points, at -1, you are getting 12 minus 24 negative value. So it is a maxima at -1, right?
यस
-3, -1, and +1. We have to think about what happens. It's a maxima at this point. And by checking the function value, you will know whether the maxima is above the x-axis or below the x-axis, right?
यस सर।
तुम थोड़ा सा एनालाइज करोगे तो तुमको ऐसा ग्राफ दिख जाएगा, मिनिमा एट दीज 2 points, मैक्सिमा एट दिस पॉइंट, राइट?
यस सर।
Okay, now what you have to think about here is मिनिमा मैक्सिमा तो ऐसे भी हो सकता था ना?
यस सर, फिर लेकिन वो 4 रियल रूट नहीं आते फिर।
हाँ, तो मिनिमा मैक्सिमा यहाँ पे 2 रूट तो गारंटीड है ना?
यस सर।
2 रूट गारंटीड है अगर मिनिमम वैल्यू इन दोनों का लेस देन 0 है, क्योंकि ऐसा भी हो सकता था।
इसमें तो कोई भी रूट नहीं है।
समझ रहे हो ना?
यस सर।
फंक्शन का शेप ऐसा भी हो सकता था, ऐसा भी हो सकता था, राइट? सो what you have to ensure is that at -3 it should be less than 0, right? Correct?
यस सर।
If it is less than 0 then यहाँ ये root is guaranteed, right?
यस सर।
You have to also check that at +1 it is less than 0. F of 1 should be less than 0. Because if it is less than 0, this root is guaranteed. Correct?
यस सर।
And then you have to check that f of -1 should be greater than 0. Right?
इससे 2 रूट आएंगे।
इससे ये 2 रूट guaranteed हो जाएंगे।
यस सर।
तो वो रीजन है, ऐसे ही यार रैंडमली वैल्यूज नहीं लेना है, राइट?
यस सर, समझ गया।
शेप ऑफ द ग्राफ इज नोन, बट वी नीड टू फिगर आउट कि कितनी बार वो क्रॉस करेगा एक्स एक्सिस को, राइट? सो दैट्स व्हाई इट वाज आल्सो इंपॉर्टेंट टू नो व्हाट हैपेंस एट वेरी लार्ज एंड वेरी स्मॉल एक्स वैल्यूज, राइट?
यस सर, वो नहीं
तभी
सोचा।
तभी पता चलेगा ना कि ग्राफ बाद में ऊपर है ऐसे कि कहीं नीचे जा रहा है, राइट?
यस सर।
आई होप इट इज क्लियर टू एवरीवन व्हाट इज हैपनिंग हियर. If you check these 3 conditions, you will get the relevant range of k for 4 real roots. Is it clear to everyone?
यस सर।
Okay, fine. The next problem is p of x is given as x power 4 plus ax cube plus bx square plus cx plus d such that x is equal to 0 is the only real root of p dash x is equal to 0. If p of -1 is less than p of 1, then in the interval -1 to 1, show that p of 1 is maximum and p of 0 is minimum. So we have a polynomial and we are given that for the derivative, only real root is x is equal to 0. Derivative is 4x cube plus 3ax square plus 2bx plus c, right? And this equation has root x is equal to 0. So x is equal to 0 is a root, that means c should be 0 because p dash 0 is 0. Correct?
यस सर।
So p dash x वाला जो function है, it is looking like x common 4x square plus 3ax plus 2b, right? Okay. Now the question has said that x is equal to 0 is the only real root of this. So that means this must not have no real roots, right? p dash x में factor है ये quadratic, but p dash x has no other real roots. So this quadratic cannot have any real roots, correct?
Yes, sir.
So this quadratic therefore will always be greater than 0. This will be always a positive number. Then only it can have no real roots because it's an upward facing graph, right?
Yes, sir.
So what that tells us is p dash x, the sign of p dash x will depend only on the sign of x, no? Because this is always positive.
Yes, sir.
Sign of p dash x is same as sign of x. So what that tells us is from -1 to 1 may, when x is positive, p dash x is positive. And here when x is negative, p dash x is negative. And here p dash x is 0. Correct?
Yes, sir.
So the graph is decreasing. The px graph is decreasing. Then this point is the maxima, minima, and then afterwards it was increasing, right? Px.
Yes, sir.
So it is obvious that p of 0 is minimum, right?
Yes.
Correct? And the maximum will be whatever is bigger, either p of -1 or p of 1, right? Do you understand that the graph is like this, downward and then upward? It depends on the endpoint values, which one is the maxima, right?
Yes.
So the maxima could be p of -1 or it could be p of 1. But in this problem, they have said that p of -1 is less than p of 1. Correct?
Yes, sir.
So again, think about how we are trying to do the question. We are always trying to think of it graphically. We are taking the derivative, we are analyzing the quadratic here, and we are thinking of it in a step-by-step manner with the graph. And you have to understand what the meaning of p dash x means. P dash x के values positive or negative होने का मतलब p of x is increasing or decreasing. So you have to know that connection, right?
Yes, sir.
Okay. The next thing I wanted to talk about today is Rolle's theorem and Lagrange's theorem. So Rolle's theorem basically says if there is a function f of x which satisfies the following conditions. First condition is f of x is continuous in the interval x belongs to a to b, and notice that this is a closed interval. This is the situation. Second condition is f of x is differentiable in the open interval a to b. And third condition is f of a is equal to f of b, right? If these three conditions are true, Rolle's theorem says there exists at least one point C belonging to A to B such that f dash C equals 0. That is the statement of Rolle's theorem. Everyone has seen this before, right? ऐसा तो नहीं होगा पहली बार देख रहे हो.
No, sir. देखा.
So the idea of Rolle's theorem is you have to have a continuous and differentiable function going from A to B, and it should be such that the values at the endpoints for the function are same. F of A is equal to f of B. If the value at the endpoints are same, no matter what kind of function it is, as long as it is continuous and differentiable, you could have many different kinds of functions. Many different kinds of functions could be there. Actually, this is not differentiable, by the way. So I should not say that. This graph is not differentiable. Why did I say that that graph was not differentiable? This straight line sort of situation.
Sir, sharp point.
Uh, there is a sharp turn, so it will not be differentiable. You have to make differentiable graphs. Always you will see that since you have to return back to the same level, somewhere the graph has to turn, right? Correct?
Yes.
And it could turn multiple times also, or it could turn just once, right? So basically the statement of the theorem is saying that there is at least one point C where the derivative f dash C is 0. And the derivative has to be 0 at least somewhere, because if it was not 0 throughout, then that means the function is either completely increasing or completely decreasing, which will never be possible if the end points are at same level, right?
Yes, sir.
I hope it is logically clear why Rolle's theorem should be true. Correct, no?
Yes, sir, correct.
So Rolle's theorem basically says that it guarantees that there will be at least one point C in that interval A to B where the derivative of C will be 0. And now using that theorem, what we can do is derive this very important idea. We will say between any two roots of a polynomial equation f of x equals 0, there exists at least one root of f dash x equals 0. So think about it. This is a very important corollary and many times it is used in problems. So what are we saying here? If you have a polynomial with multiple roots, let's say we have a cubic polynomial. This is an example of a cubic polynomial. It has 3 roots, right? Now, what the root theorem is saying is between any two roots of the polynomial, there is at least one root of the derivative. So the derivative f dash x will become a quadratic, right? And what we can say, because we know that every polynomial function is always continuous and differentiable for all x, we can always apply Rolle's theorem if you can find 2 points where the values of the polynomial are equal, right?
Yes, sir.
So if this polynomial, you can see that this point and this point, the two roots alpha, beta, gamma, 3 roots. You can always use Rolle's theorem between these two because the values of f of alpha and f of beta are equal. So if you use Rolle's theorem here, you are guaranteed that there will be some point C1 here such that f dash C1 is 0, right? Similarly, between beta and gamma, there will be some point C2 such that f dash C2 is 0. This point is C1, this point is C2. And between any two roots of the polynomial, we are finding one root of the derivative. And these C1 and C2 are the roots of the derivative quadratic. Is it clear why it is a direct Rolle's theorem application?
Yes, sir.
Okay. So Rolle's theorem should be obvious. Now the next theorem that we need to understand is LMVT, Lagrange's mean value theorem. So this is actually the real theorem and Rolle's theorem is a special case of this. Okay. So let's understand this properly. We say let f of x be a function which satisfies the following conditions. First condition is f is continuous. First couple of conditions are same as Rolle's theorem. So fx continuous on a closed interval, and second condition is f is differentiable on the open interval x belongs to a to b. Now, there is no further condition in Lagrange's theorem. In Rolle's theorem, we had a third condition that f of a is equal to f of b. Here, f of a does not need to be equal to f of b. Okay? And we can say that there exists a point C belonging to AB such that f dash C is equal to f of b minus f of a divided by b minus a. So this is the statement of Lagrange's mean value theorem, that if the following two conditions are satisfied, then automatically there will be a C in the interval a to b, which will always satisfy this. Now, there is an easy way to understand this. Logically, you can understand the theorem. You can say that you have a graph like this. What we are saying is, one second. Let's say this is my graph of the function. It is going from x is equal to a to this point where x is equal to b. And the value of the function here is f of a. So the point here is a comma f of a, and this point is b comma f of b. Now, what is the value? What is the meaning of f of b minus f of a by b minus a? Think about it. Geometrically, what do you think is the meaning of this? This is the slope of this line, no?
Yes.
Slope of the line joining the endpoints. Line joining endpoints of the interval. And basically, you can also think of it as a change in y by change in x over the whole interval, right? Change in y is the f of b minus f of a. Do you understand what I'm saying?
Yes, sir.
So, the right hand side of Lagrange's theorem, f of b minus f of a by b minus a, is basically the total change in y by total change in x, which is the average rate of change of f of x over the whole interval, right? Basically, it is saying ki how fast is f of x increasing? How much was the change in y per unit change in x, which is basically the average rate of change of the function, right?
Yes, sir.
So if that was the average rate of change of the function, now the theorem is saying that there has to be a point in this interval from a to b where the slope of the tangent is going to be equal to the slope of the chord. This is my chord, this is my tangent, and I'm saying that f dash c, this point is at x is equal to c, slope of tangent is f dash c. Lagrange's theorem guarantees that there is at least one point in this interval a to b where the slope of tangent is equal to the slope of the chord, which basically tells us that there is at least one point where the instantaneous rate of change of the function will be equal to the average rate of change of the function. There could be more than one such point. There could be, this point is also having the tangent with the same slope as the chord, right? Do you understand what I'm saying?
Yes, sir.
So Lagrange's theorem says f dash c should be equal to this, and there is a c like that in that interval. Notice that if f of a is equal to f of b, then Lagrange's theorem becomes same as Rolle's theorem, because f dash c will be equal to 0 then, right?
Yes, sir.
So Lagrange's theorem's special case is Rolle's theorem, but you need to understand why. Logically, why is this true? There must be a point where the slope of tangent is equal to the slope of the chord. Why is it logically true? Someone think about it and give me a realistic explanation, physical explanation.
So please repeat आपने क्या पूछा?
You need to explain why should there be a point where the slope of tangent is equal to the slope of chord. Or can you explain logically why Lagrange's theorem should be correct? So one simple way to explain it is think of you going on a trip from your city to a nearby city. Suppose it was 200 kilometers and you took 4 hours to reach the other city, right? What was your average speed? 200 kilometers, you took 4 hours. What was your average speed?
50 kilometer per hour.
Right. But average speed was 50 kilometer per hour. Can you say that obviously your whole speed over the whole journey would not have been constant 50 all the time, right?
Yes, sir.
Your speed could have been more or less than 50, right? Correct.
Yes, sir. Correct.
Lagrange's theorem is saying that there has to be at least one point in this whole journey when your speed was exactly equal to the average speed of 50. Why is that supposed to be correct? Think about it. Can you do the whole journey at lower than average 50 speed?
At the same time, no, sir.
Obviously, at the same time only, no, 4 hours में खत्म करना है journey.
No, sir.
You can never go 4 hours, 200 kilometers if everywhere your speed was lower than 50, right?
Yes, sir.
Similarly, you can never go take 4 hours for the journey if all the time your speed was above 50, right?
Yes, sir.
So that means your speed must have crossed 50 somewhere in the middle, right?
Yes, sir.
Yes, sir.
So your instantaneous speed must have crossed the 50 level somewhere. And we are guaranteed that it actually takes the value 50 because we are assuming continuous and differentiable functions. So suddenly your function cannot jump from 49 speed to 52 speed. Do you understand what I'm saying?
Yes, sir.
Yes, sir.
So basically, the theorem is explaining that if a function is growing from a certain value to a certain value at a certain average rate of change over an interval, and if the function was continuous and differentiable, then there must be a point in that interval where the exact rate of change, the instantaneous rate of change, or the derivative of the function is equal to the overall average rate of change, right?
Yes, sir.
That is your LMVT. Technically, it is out of syllabus now, but you still need to know it properly and understand it in case some question comes. I don't know whether it is in NCERT or not. Is it there in your 12th grade math syllabus?
No, sir.
NCERT? No. Okay. Okay, fine. But it's important to know these two anyway, because in polynomials and all, we saw there was an application, right, in normal equations. Between any two roots of f of x equals 0, there is a root of f dash x equal to 0. So that application will become useful in problems later on. With that, we have discussed more or less the whole theory: tangents, normals, maxima, minima, increasing, decreasing, and the mean value theorems. Tomorrow we'll do a class in the morning and we will discuss the sheet, the AOD sheet. So if you have attempted the AOD sheets, then come to me with the doubts and all. We'll discuss some of the doubts in those sheets tomorrow. Okay.
Yes,
Sir, actually, I've joined the course a bit late, so I don't have access to the sheets.
You can
Is
ask
there
on the group, everyone will share the sheets with you.
Okay, sir.
Just ask on the group, everyone else will have the sheets, they will share it on the group, right?
Okay, sir.
Okay, so we'll discuss the problems of AOD tomorrow, and then day after tomorrow onwards, I want to start straight lines and circles and all. By the way, if you see, I will share the playlist. There are several playlists on the channel for circles and stuff. So If you need videos to revise the theory, please use the channel videos to revise it. There are enough videos on the channel, and I've made a playlist for circles. I will make a similar playlist for straight lines. Do you understand what I'm saying?
Yes, sir.
There are enough videos on the channel for the theory part. You need to put in that time and make sure your theory is revised, because we might not have enough time to do complete deep dive into theory right now. We will have to quickly get into problems and understanding how to do problems. Okay. So use the coordinate geometry playlist on the channel, and I will create a separate straight lines playlist. Already a circles playlist has been created and a complex numbers playlist has been created. So whatever chapters I have done in the past, I'll try to group all the videos together. You can use them for your revision. Okay.
Yes.
Okay. That's all for now. I'll see you tomorrow morning.
ओके सर। सर कल की क्लास की टाइमिंग क्या है सुबह मॉर्निंग में?
I will try to keep it at 9:30 a.m.
ठीक है सर।
Okay. So we'll discuss the doubts of AOD tomorrow. Okay. That's all for now. I'll see you tomorrow then.
ओके सर, थैंक यू सर।
Bye.